Hello, this is Heather Connor, and this is my semester summary for Physics 112, and I'm going to now discuss my Physics 112 journey. Directly from the syllabus, the course competencies required for the course were to effectively communicate qualitative and quantitative information orally and in writing, explain the application of fundamental physical principles to various physical phenomena, apply appropriate problem-solving techniques to practical and meaningful problems using graphical, mathematical, and written modeling tools, work effectively in collaborative groups, evaluate scientific claims based on the actual nature of science, argue various sides of scientifically controversial debates using appropriate scientific argumentation techniques, and communicate technical information using various media and Web 2.0 applications. I'm going to spend this hopefully less than 15-minute presentation. I'm a little bit wordy, so I don't know that I can keep it within that time, but I'm going to do my best. I'm going to show you what I did during the semester and how I met these course competencies and why I am more than deserving of an A for this course. In Unit 1, we learned about static electricity and the way that opposites attract and like charges repel. In the first week of class, we did a fun with sticky tape experiment. We did simulations later on about John Travoltage, a sweater and balloon simulation, and this was the first real topic that we discussed that would end up having a thread run throughout the whole course as we talked more about electricity and magnetism. Also in Unit 1, we talked about electromagnetic radiation. We talked about light, how it is both a wave and a particle. We did a geometric optics simulation. We learned about photons. We learned about different wavelengths of light, different colors of light, many things about that. Unit 1 also included project number 1, which is the solar cooker project, and in that we were learning about how light energy can be converted into heat. We'll talk about project 1 a little bit more later. Unit 2 was all about electricity. We learned about charges, forces, and fields, resistors, direct and alternating currents, how direct current will run in one direction, alternating current. Current is constantly changing directions. We learned about the physics classroom website, which was incredibly useful throughout the rest of the semester. There were pen casts. We had circuit simulations where we were asked to build both series and parallel circuits. We learned about electrical safety. We had pen casts on semiconductors. We learned about energy, power, conductivity, resistivity. There was an assignment to research and define insulators, semiconductors, conductors, and superconductors. And it also included the project number 2, which was building solar panels. And in that, we were learning how solar energy can be converted into electricity. Unit number 3 was all about magnetism. We learned about different types of magnets, permanent magnets, earth magnets. We learned about charges, which also tied into the static electricity topics from before. Learn about acceleration of charges, electrical transformers, electrical field and magnetic field induction. And that I mean when you have an electric field through current, a magnetic field is induced, and in inducing that magnetic fields also induce electrical fields. So it's a constant flow of these two things happening. It's perpetual. When you have an electric field induced, when you have an electric field, you'll induce a magnetic field. When you have a magnetic field, you'll induce an electrical field, and it's a big loop. We learned more about semiconductors and circuits. There were pen casts on these things, and we also completed project number 3, which was building a coil gun. We'll talk more about that later. And in Unit 4 was the wrap-up for the semester. We learned about relativity. We had a pen cast. There were neat resources associated with relativity. We learned about quantum mechanics, how things work on a very small scale. Previous semester of physics I talked about large scale, and we talked about a large scale a little bit in this class as well, but relativity or quantum mechanics was talking about a small scale. We learned about nuclear and atomic physics, what nuclear fission and nuclear fusion are. Fission is breaking apart of atoms, and fission is breaking apart of the nuclei, and fusion is fusing nuclei. And we had a special topics section. There was string theory briefly in this unit, and we had project number 4, which was to talk about and research a current modern application of physics in today's life, and we did satellite power cells in my team, and we'll talk about that a little bit more later. So for projects, project number 1 involved building a solar cooker. I built a box-type solar cooker. There were 4 members of my team for this project. I shot video and photographs, numerous. I created slides answering the requirements of the assignment. I created graphical representations of my results. Brian Abbott was the leader of this team. He compiled the final Prezi, which was submitted. There's a link here to view that for your ease of use. And I completed the team member assessment posted on Blackboard. Project number 2 was the solar panel. We were required to build a solar panel out of broken solar cells that we soldered together in series. I shot numerous videos and photographs of this. I created the Prezi, compiled the final Prezi of the 4 group members' activities. I was the team leader for this project. The Prezi was submitted by me. There's a link here for that Prezi. And I also completed the team member assessment posted on this Blackboard. Posted on Blackboard. It was after this project that I found that my team was not getting 100% commitment from all members, and with David's approval, we were broken up, segmented out a little bit, and all later projects 3 and 4 were completed just by Brian and myself. So project number 3 was to build a coil gun that was capable of propelling a metal projectile using the theories of electromagnetism. An electrical current was run through some magnet wire, which induced a magnetic field, which propelled a metal projectile through a barrel that we created through the inductive effect of current and magnetic fields. I shot videos and photographs of this. I created the Prezi, compiling the information submitted by myself and Brian. I was the team leader for this project. I submitted the Prezi, which the link is available here, and there was no team member assessment for this project. The final project for the class was project number 4. Brian and I created a presentation on satellite power cells. I contacted industry sources and conducted an in-person interview of a gentleman, Michael Mikowski, who works for Orbital Sciences in the Valley. I shot video of this one-on-one interview. I helped create slides. I created the study guide and quiz with input from Brian. Brian was the team leader for this project. He narrated the PowerPoint and compiled the PowerPoint together and submitted that. The YouTube link for the narrated PowerPoint is provided. There were also YouTube videos of the interviews available, and there was no team assessment available for this project. I'm going to exit out of this for just a minute to check my time. So we are about halfway there. Let's keep going. So that was all of the projects in a nutshell. We're going to talk about other things that we did during the semester and how I meet all the criteria required for an A. Oh, in addition, let me backtrack for just a minute. In addition to doing our own presentation for project number 4, we were also required to watch the other project number 4 presentations and review study guides and take quizzes. The topics that I watched and reviewed were cold laser therapy, physics of space and flight, nuclear fusion, although I wasn't able to get that Prezi to load, dark matter, LASIK eye surgery, MRI, and cyberknife applications. Throughout the semester, there were various topics that were posted on the discussion board that required students to either watch a video, read a paper, visit a website, do something of that nature, and then respond to what we saw. Throughout the course of the semester, I read all required papers, watched all required videos. I wrote responses to each discussion board post myself. The requirement for an A is only 95%. I exceeded that. I read all other students' responses and chose to respond to some, even if it was a brief interaction. I wanted to get some conversation going. The topics that we covered through the semester were 3 questions. What is physics? What is science? Those types of things. We had introductions, the nature of science, which was a paper written by David, 4-dimensional thinking, a vision of students today, did you know shift happens, boys, gaming, and education, engage me or enrage me, the educational value of creative disobedience, and digital nation. In addition to that, before the end of the semester, there was a 3-part Elegant Universe PBS video series that I watched. There was no discussion board posting, but I did view and take notes on string theory. It's a very intriguing concept. I definitely see the point of how it delves more into the realm of philosophy over science. In my humble worldview of science, I believe that the premier tenet of science is the ability to falsify data. And there is no way to falsify these theories because there's no way to observe or conduct experiments on string theory currently. But I'm excited to see where this field may progress. So those were all the special discussions and videos. I certainly meet the criteria for an A in that. We also were required to post a neat resource nearly every week. In this, the syllabus requires that you post a unique neat resource that has not been posted prior to your posting. I made very sure that I did not duplicate anybody's prior posting, although some of my, I did find later on as people posted later that there were maybe some duplication, but it was not by me. I included a 50-word abstract for each neat resource posting. I viewed every other neat resource that was posted by other students and responded to each one, which was required for an A. I have provided in very small type a link to all of the neat resources that I've posted throughout the semester. In addition to the neat resources, we were required to post either a weekly summary or unit summary as appropriate each week. I completed all weekly summaries on deadline. In each weekly summary, I included what I did, what I learned during the week, how it applied to my life, photographs and videos of my journal as appropriate, and the amount of time I spent each week on class materials. The requirement in the syllabus was 3 to 5 minutes in length for each of these videos. In many cases, I exceeded that length. I don't know whether that's a good thing or a bad thing, but I can't seem to help myself. I'm a little talkative. I've also provided an easy link access for all my weekly summaries here for you. I did one unit summary for the semester. I completed that on deadline. I included a summary of what I did, what I learned, how it applied to me, images of my journal, and the amount of time spent on class material. This was all the requirements required for an A, and I had to break that up into 3 parts for my unit summary, and those are provided below. We had a cultural science assignment. I visited the Arizona Science Center. I composed a 3-page report on this visit that included videos and photographs. There were also sources that were provided that were used throughout the paper. This far exceeded the 2-page requirement for an A. The paper was emailed to the instructor before the deadline, to you, David, and I also posted on the discussion board. And the link to the videos of the visit are below. The biggest assignment beyond the projects in this case was definitely the controversial debates topics. I wrote researched paragraphs where I used Science Direct to find academic resources and citations for my paragraphs. I followed the syllabus guidelines of using unique topics that were not previously touched on by other students that had posted prior to me. I also responded to all pro and con arguments of other students, in that in some cases I responded to 100% of postings for some topics. As I went along through, I found that some arguments were being touched on more than once, so I chose to respond to all the unique points of arguments as far as I could tell. And in those cases where I didn't respond to 100% of the postings, I did respond in general to all pro and con arguments for each topic. So you will find that I have responded to 100% of the pro and con arguments. Perhaps not 100% of all topics, which in this case would have been, at most, there were 16 topics, pro and con for each one, approximately 16 students. There would have been over 400 responses I would have had to make. I did do several hundred. I just meant I wanted to make sure that I was responding in some cases to the topic in general, and in some cases to specific arguments. So I believe that I have met the criteria for an A in this assignment. I showed my journal activities. There were several weekly summaries and in the unit summary that showed the documentation of my journal. I am very much a note taker, so I filled over 100 pages of notes. There are screenshots available in some discussion board posts, and I provided a YouTube video of my final journal for your perusal. So, in summation, I want to talk about how I met the course competencies. We were asked to effectively communicate qualitative and quantitative information orally and in writing through the weekly summaries, the prezzies, the videos shot, the papers written, and the postings. I believe that I have shown that I can do qualitative information. Quantitative information was certainly present in the projects, the graphs, the tables, and charts that were provided in those. We were asked to explain the application of fundamental physical principles to various physical phenomena. We did that throughout the semester, and used the projects to show how we were able to do that. We learned about solar cookers and how light energy converts into heat. We talked about solar panels and how solar energy can be converted into electricity. We learned about current inducing a magnetic field and how that can be used to propel propel metal objects. In addition, we were asked to apply appropriate problem-solving techniques to practical and meaningful problems using graphical, mathematical, and written modeling tools. I believe through the projects we've shown that I've done that. Problem-solving techniques were definitely required for some of the projects for me. I had a great deal of problem meeting the requirements for the solar cooker. I never got my water to boil, but I did get it to raise in temperature. I had difficulty with my solar panel. I initially got a light bulb to light, but was never able to get